Gold is one of the few things on Earth that never truly dies. It only waits to be reborn. Hidden within this tangled mess of broken alloys and forgotten heirlooms is a fortune. Today, we're going to strip away the copper, the silver, and the dirt, using advanced chemistry to reclaim the treasure inside. This is the art of refining. Watch as we transform scrap metal into a bar of 99.99% pure, elemental gold. The journey of gold is eternal, shifting shapes but never losing its intrinsic value. Today, we witness a transformation. We begin with a collection of the past, old rings, broken necklaces, and forgotten heirlooms that have served their purpose. These pieces are currently a mix of alloys, likely 14 or 18 karat, containing copper, silver, and zinc mixed with the gold. Our goal is to strip away everything that is not gold, returning this metal to its elemental, 99.99% purity. The first step is the weigh-in, establishing a baseline mass for our scrap metal before the fire touches it. We place the scrap into a high-temperature ceramic crucible, a vessel designed to withstand the intense heat required for melting. A sprinkle of borax is added to the mix. This white powder acts as a flux, helping the metal flow and preventing oxidation. The torch is ignited, roaring to life with a blue flame that will bring the temperature inside the crucible to over 1,000 degrees Celsius. Slowly, the distinct shapes of the jewelry begin to soften, slumping down as the lattice of metal atoms begins to break apart. The metal turns a glowing cherry red, then a bright orange, and finally, it collapses into a shimmering, liquid pool. We stir the molten metal with a carbon rod to ensure a homogeneous mix, verifying that no solid lumps remain hidden at the bottom. With a steady hand, the glowing liquid is poured into a vast bucket of water, a process known as shotting or graining the metal. The sudden thermal shock creates popcorn-like shapes, vastly increasing the surface area of the gold for the chemical reaction to come. We now have cornflake gold, still impure, but physically prepared for the aggressive acid digestion that follows. The gold grains are transferred into a large borosilicate glass beaker, capable of resisting strong acids and high heat. We begin the chemical refining process, often referred to as the aqua regia method, the king's water, capable of dissolving noble metals. First, we pour in hydrochloric acid, covering the gold completely. The liquid remains clear, as this acid alone cannot touch the gold. The magic happens with the addition of nitric acid. We add it slowly, drop by drop, to control the violent reaction that is about to occur. Immediately, the solution turns a vibrant emerald green and begins to bubble fiercely, releasing reddish-brown nitrogen dioxide fumes. This reaction is dissolving the gold, turning it into chloroauric acid, while the copper and other base metals also dissolve into the solution. We place the beaker on a hot plate to accelerate the digestion, watching as the metal grains slowly disappear into the dark liquid. If there is silver present in the jewelry, it will not dissolve but instead turn into white silver chloride sludge at the bottom. Once all the metal has dissolved, we are left with a dark, murky liquid that holds our gold in a suspended, ionic state. We must now filter this solution to remove any solid impurities, trash, or silver chloride that would contaminate our final product. A vacuum filtration flask is set up with a Buchner funnel and a fine filter paper to catch even the smallest microscopic particles. The dark liquid is poured through. The vacuum pulls it down, leaving the gray sludge of silver chloride and dirt on the paper. What drips into the flask below is a crystal clear, emerald green liquid. This is our gold, hidden within the acid solution. We rinse the filter paper with distilled water until the paper is white, ensuring every drop of gold-bearing liquid is captured. The solution is now clean, but it still contains nitric acid. We must neutralize this excess acid before we can recover the gold. We add sulfamic acid to the hot solution. It fizzes rapidly, a process called denitration, converting the nitric acid into harmless gases. We continue adding sulfamic acid until the fizzing stops completely, indicating that the environment is ready for precipitation. Now comes the most visually satisfying moment: the precipitation. We need a chemical that will force the gold to drop out of the liquid. We dissolve sodium metabisulfite in warm water and slowly pour this reducing agent into our green gold solution. The reaction is instant. The emerald green color vanishes, replaced by a muddy brown cloud that swirls through the beaker. This brown mud is actually pure gold dust. The chemical reaction has disconnected the gold from the chlorine, forcing it to solidify. We allow the beaker to settle for several hours. Slowly, a heavy layer of brown powder accumulates at the bottom of the glass. The liquid on top is now clear or light blue, indicating the copper remains in the water, while the gold has successfully separated. We carefully decant, or pour off, the waste liquid, being extremely careful not to disturb the precious brown sediment at the bottom. This brown powder is 99.9% pure gold, but it is currently dirty, with chemical residues that must be washed away. We begin the washing phase with boiling tap water, stirring the mud vigorously to dissolve any remaining copper salts. After the gold settles again, we pour off the water and repeat the process, this time using hydrochloric acid for a deep clean. The acid wash removes any stubborn traces of other metals that might be clinging to the microscopic gold particles. Finally, we rinse the gold powder multiple times with distilled water until the water runs perfectly clear and has a neutral pH. The wet gold mud is transferred into a drying dish and placed on the hot plate to evaporate the remaining moisture. As the water evaporates, the dark mud lightens in color, turning into a light brown, clay-like substance that is dry to the touch. This is it, pure elemental gold. It doesn't look like jewelry yet, but chemically, it is perfection waiting to be reborn. We prepare a clean crucible, seasoning it with a layer of borax to ensure the pure gold glides smoothly when poured. The brown powder is scooped into the crucible. It looks like dirt, but it is about to undergo a spectacular metamorphosis. The torch returns, but this time we use a softer flame initially to prevent the fine gold dust from blowing away in the wind. As the heat builds, the brown powder begins to darken and shrink, the particles sintering together as they approach the melting point. Suddenly, the dull powder flashes and transforms into a liquid mirror. The transition from dust to metal is instantaneous and beautiful. The molten sphere spins in the crucible, a perfect bead of high-purity gold, reflecting the light of a torch with intense brilliance. Impurities would appear as dark spots spinning on the surface, but here, the surface is clean, smooth, and uninterrupted. We prepare a graphite mold, heating it slightly to remove moisture and ensure the gold travels smoothly into the rectangular shape. With a steady, practiced motion, we lift the crucible and pour the heavy, liquid sunlight into the waiting mold. The gold fills the cavity instantly. We watch as the orange glow begins to fade, the metal solidifying from the outside in. The gold fills the cavity instantly. We watch as the orange glow begins to fade, the metal solidifying from the outside in. As it cools, the gold undergoes crystallization. You can sometimes see distinct patterns forming on the surface as the atoms align. Once the red glow is gone, we tip the mold over. The bar falls out with a heavy thud, a dense, solid brick of value. It is immediately quenched in water to cool it completely, producing a sharp hiss of steam as the temperature drops. We retrieve the bar. It currently has a matte finish, perhaps slightly discolored from the borax flux used during the melt. To reveal its true beauty, we submerge the bar in a warm sulfuric acid pickle solution to dissolve the surface glaze. After a few minutes, we remove the bar and scrub it under running water. The dullness vanishes, revealing the rich, deep yellow of 24K gold. The color is distinctively different from the 14K jewelry we started with. It is deeper, warmer, and undeniably pure. We take the bar to the scale for the final weigh-in. The numbers settle, telling us exactly how much pure wealth we have recovered. To complete the presentation, we use a metal stamp to mark the bar with its purity, 99.99, the sign of 4 nines fine gold. The hammer strikes the stamp, leaving a crisp, permanent indentation in the soft metal, certifying its quality for the future. We polish the surface gently with a soft cloth, removing fingerprints and dust, letting the studio lights play across the face of the bar. This bar represents not just wealth, but the power of chemistry and the satisfying cycle of destruction and creation. From a pile of broken, forgotten scraps, we have distilled the essence of the metal, creating something timeless and perfect. The refining process is complete. The impurities are gone, the history is wiped clean, and only the element remains. Thank you for joining us on this mesmerizing journey of purification. The transformation is now complete. There is a profound satisfaction in seeing order restored from chaos. The transformation is undeniable. What started as a confusing mix of 14 and 18 karat alloys has been distilled down to its singular, perfect essence. This bar now holds the highest standard of purity possible. It is no longer jewelry. It is a store of value that will last forever. If you found this process as satisfying as we did, please like and subscribe for more precious metal transformations. Thank you for watching.